Hey everyone, we're going to wrap up the rest of these notes with this last video. This is the last problem that is in the notes on continuity. So it says to verify that the intermediate value theorem applies to the following function f of x over the interval 5/2 to 4, and explain why IVT guarantees an x value of c, where f of c equals 6, and find c. So there's a lot of things going on in this problem. Okay, remember, in order to be able to use the intermediate value theorem, our function has to be a continuous function in that closed interval that's provided. So if you look at this rational function, you'll see that there is a vertical asymptote at x equals 1. So you might think, oh, but it's not continuous. But that x equals 1 is not within this interval, right? If you think of your number line here, here's 1. 5/2 is 2.5, right? So if 2, 3, and 4. So really we're going from here at 2.5 or 5/2 to 4. So this is the interval we're looking at right here. Okay, so our function is continuous in this interval because our asymptote would be over here at 1. Okay, so because it is continuous, then what we need to do is, let's see, applies the following function over the interval. Explain why it guarantees an x value of c, where f of c equals 6, and find c. Okay, so the first thing we can do, first thing we did show was that it's continuous, or we verified that it is continuous. Then the next thing we're going to do is find what our function is at the endpoints of that interval. So we're actually going to figure out what f of 5/2 is, and then we'll figure out what f of 4 is. And in the interest of time, I'm going to just do this on the calculator. So let me pull up my calculator here. And what we can do is we can just put this function in our calculator. And let's see if I change this. X squared plus x over x minus 1. And if we go ahead and take a look at the table, right, I can clear all, well, actually, I can just go ahead and put these in. So we're going to put in 5/2 or 2.5, and that will tell us what our y value is. That was 5.8333. And then we'll do the same thing for f of 4. And you'll see those first two entries in the calculator have changed. So I got 5.83 repeating and 6.6 repeating. So we've got 5.833 and 6.667. Now, since 6, this value here falls between 5.833. So since 5.833 is less than 6, is less than 6.667, then we can say by the intermediate value theorem, or by IVT, there is a c where f of c equals 6, where f of c is equal to 6. Okay, so remember we said if our c value is between 2.5 and 4, then we get an f of c value between this 5.833 and this 6.667. So we had to determine those values first and show that 6 was between those, and then that tells us that that part of IVT has been verified. The next thing we have to do is now find the c value that is between 5/2 and 4. So we're finding it where f of c is equal to 6. Okay, so what we're actually going to do is say x squared plus x over x minus 1 is equal to 6, and we're going to go ahead and solve that. Okay, so let's go ahead and solve this. If we take this from a rational function into just, if we just cross multiply, we'll get rid of the fraction. So we end up with x squared plus x is equal to 6x minus 6, right? I just multiplied 6 times x minus 1. And now I'm just going to bring everything over to one side. I'll do that up here. So I end up with x squared minus 5x plus 6 is equal to 0. When I factor that, I have x minus 2 and x minus 3. And so when I solve that, I get x equals 2 and x equals 3. Now, 2 does not fall in the interval from 2.5 to 4, so we can just eliminate that one. And so our x value, or our c value, right, because it said to find c, so that's basically what we just did. Okay, we just left everything in terms of x, but it's really f of c because we let that equal 6. Okay, so this value is guaranteed by the theorem. So let's walk through one more time what we just did. Okay, so first thing we did, we said in order to use the intermediate value theorem, we have to have a continuous function within the interval. And we realize that this is continuous everywhere except at x equals 1, but 1 isn't in the interval from 5/2 to 4, right? That doesn't fall within the interval. Okay, so we know it's continuous within that given interval. And so the intermediate value theorem says if you have a c value that is within this given interval, if you have an x value or a c value that is within this given interval, you are guaranteed an output value that is between your outputs of your interval. Okay, so let me say that one more time. You are, by the intermediate value theorem, if your function is continuous, if you have an input that's that is within the interval between your minimum and your maximum value of the interval, you are guaranteed an output that is between the output of that minimum value and the output of that maximum value. Okay, so 6 falls between our two outputs, so we've satisfied that condition. That tells us that there is definitely going to be a c where f of c equals 6, and then we just had to find that c. So what we did was we took our original function and set that equal to 6 and found that x value. And that 3 falls between 2.5 and 4, so I know that that's the x value that I'm talking about. Okay, so that's the intermediate value theorem. That should help you with the assignment. We'll see you guys next time. Thanks, everyone.